So, hello everybody and warm welcome for this next Angst+Pfister Sensors and Power webinar. This time we will show you a bit more of our gas sensors. We means it's me, Volker Huelsekopf. I'm Key Account Manager here at Angst+Pfister Sensors and Power, and my colleague Dr. Nauman Tanvir. He will introduce himself a bit later. The webinar now is supposed to last about 30 minutes. And during that time, we will show you more about the technologies that we are selling, that we are offering as solutions, something about the applications and some more insights. During the webinar, we will do some questionnaires, some polls where you get answered some questions on your application or your technology. And we will be more than happy if you could answer these and share some information with us. At the end, there will be a Q&A session. You are, of course, able to send some questions anytime. If you look on the bottom line of your screen on the right side, there is a little button named questions, and you can type in whatever you want to share with us. So, but now I think I will stop and I will lead over to Nauman to start with the webinar.
Hello and warm welcome to all of you for joining this webinar titled Optimize Your Application with Our Oxygen Sensors. My name is Dr. Nauman Tanvir and I am responsible for the gas sensing business segment at Angst+Pfister Sensors and Power. Today I will be presenting you different oxygen measurement principles that we have developed at Angst+Pfister over the period of more than 30 years. Subsequently, I will be linking different aspects of our gas sensors with respect to many different application areas in order to correlate highlights of different oxygen principles with respect to certain applications. Let's start with the agenda. As a starting point, I want to very briefly introduce you to Angst+Pfister as a company. This will be followed by an introduction towards the gas sensing team. In the next phase, I would like to give you an overview of different technological breakdown of our oxygen gas sensor portfolio. And in the last phase, I will give you some insights to some of the most relevant application areas and explain why certain technologies for oxygen sensing are more suitable for certain applications in comparison to the others. This will be followed by a Q&A session where we look forward to receive your feedback and at the same time we'll review your questions with which we can support you better. During this whole webinar, we will also be conducting 3 different surveys. We invite you to take part in all of these surveys in most active way possible, as these questions really help us understand your application. And in addition, help us to optimize our sensors according to your application requirements. With that said, let's move towards our first survey. Welcome back. Let's start with the introduction. Angst+Pfister is more than 100-year-old company. It was founded in 1920 and is one of the leading global supplier of technical components and customized solutions. Our main areas of competence lies in the field of industrial sealing technology, vibration control, molding solutions, and last but not the least, sensors and power. Angst+Pfister Group maintains a very strong global presence with operations in over 50 countries spread all over the world. With such a vast footprint, the company employs more than 1,200 employees, which serves more than 20,000 customers all over the world. Our extensive network of employees and worldwide presence enables us to provide localized support, rapid delivery, and tailor-made solutions to our clients all over the world. Subsequently, Angst+Pfister Sensors and Power Group is a distinguished leader in providing innovative sensor solutions and power transmission components for a wide range of industries worldwide. Our group is mainly divided into 4 subsegments, among which today we will mainly be focusing on the gas sensor business segment. This is how our gas sensing team looks like, with more than 30 years of experience in the field of gas sensing. So if you have any requirement of any gas sensor in your application, please contact any of us anytime. With that said, let's move to our next survey. Moving forward, let's dig a little deeper into the technological aspects of our oxygen sensing portfolio. Let's start with the amperometric zirconia, or in other words, zirconium oxide oxygen sensor. An amperometric zirconia oxygen sensor operates on the principle of oxygen ion conductivity through a zirconium dioxide solid electrolyte layer. This works by a combination of a high potential field and a diffusion limited flow. The basic principle involves the measurement of the electrical current that flows through the zirconia electrolyte when a voltage is applied across it in the presence of gas containing oxygen. As for our portfolio using amperometric zirconia is concerned, we offer most versatile and flexible approach to our customers. The sensor modules are available in either diffusion or flow-through configuration, and similarly on the output side one can have many different options integrated into the module that can work from analog signal to any kind of digital signal variants. Next, let's talk about the potentiometric zirconia oxygen sensor. The potentiometric principle works by oxygen mass indifference between 2 opposite electrodes. A balanced potential that counteracts the indifference is measured between the 2 electrodes as described by the Nernst equation. In comparison to amperometric zirconia, the potentiometric zirconia oxygen sensing principle uses the voltage generated across the zirconia electrolyte due to the indifferences in oxygen partial pressure. As for our portfolio using potentiometric zirconia is concerned, we offer highly reliable and highly accurate sensors which are available in both diffusion and flow-through type configurations. Lastly, I would like to introduce you to the paramagnetic oxygen sensing principle as one of the most selective methods for the detection of oxygen in any application. A paramagnetic oxygen sensor operates on the principle that oxygen molecules exhibit paramagnetic properties, meaning that they are attracted by a magnetic field. In this sensor, a gas sample containing oxygen is exposed to a magnetic field, causing the oxygen molecules to align with the field. The working principle is based on the measurement of force that is required to keep a nitrogen-filled glass dumbbell under a magnetic field at its original position. The electrostatic force required to keep the dumbbell at its original position is directly proportional to the oxygen concentration. The paramagnetic oxygen sensors are valued for their high sensitivity, rapid response times, and minimal interferences from other gases, making them suitable for many different applications, which will be discussed in detail in the next section. We offer a paramagnetic oxygen sensing portfolio in both standalone sensor, that is the Parox 1200, and on top we also offer the sensor integrated into different housings together with different accessories and other target gas combinations. Till now we have introduced you to different technological aspects of oxygen gas sensing, but now I would like to dig deeper into the typical use cases and the application areas for these different types of oxygen sensing principles. Let's start with amperometric zirconia. When we talk about typical application areas, we can start with CO2 incubators, followed by oxygen concentrators and generators. Another application area where typically the oxygen sensor is needed is food storage and packaging industry. Apart from these, there are many other different application areas where amperometric zirconia sensor can be successfully employed for the detection of oxygen. Now the question would be why an amperometric zirconia is the right choice for such and many more applications. And the answer to this question lies in many outstanding features which this technology can offer in comparison to other available technologies. These features mainly include long lifetime and highly reliable measurement with low drift, lower power consumption, very fast response and recovery times, an excellent long-term stability, possibility of measuring oxygen at higher ambient temperatures, and lastly, we at Angst+Pfister offer very flexible design-in and engineering support, which suggests that we are ready to propose customer-specific design features that could suit and fit your application requirements. Next, let's move to the potentiometric zirconia. One of the most interesting application areas for such type of oxygen sensors is additive manufacturing or metal 3D printing. Generally, this application requires a very accurate measurement of oxygen at lower ppm parts per million level, as the slightest amounts of oxygen present in the printing chamber can have a drastic influence on the printing quality. Such accurate measurement of oxygen at lower ppm levels can be reliably attained by the potentiometric zirconia oxygen measurement principle. Subsequently, industrial process control is another well-known application area where potentiometric oxygen sensors can be successfully deployed. And last but not the least, energy systems such as fuel cells and electrolyzers are also very interesting application area for the potentiometric zirconia oxygen sensors. And again, these are very few among many application areas where potentiometric zirconia can be successfully deployed for the detection of oxygen. Let's now talk about the features and highlights of potentiometric zirconia sensing, which makes it one of the most robust technology for many different application areas. Again, they offer very long lifetime as there are no consumable parts in the working principle. They offer a wide range for the detection of oxygen with very high accuracy, which makes it very useful for challenging applications such as metal 3D printing. They offer very fast response and recovery times. They are very stable in operation with low drift. They can be deployed for the measurement of oxygen at higher temperatures as well. And again, at Angst+Pfister, we offer full design-in support that can include gas pre- and post-treatment for the integration of this type of sensor in your application. Lastly, let's move towards the typical application areas for the paramagnetic principle of oxygen sensing. One of the most challenging applications where oxygen detection is typically required to optimize the fermentation process is biogas plants. The low cross-sensitivity of paramagnetic oxygen sensor makes it an ideal candidate for biogas power plants. Similarly, emission monitoring, typically called as SEMS, is also another very interesting application area for paramagnetic oxygen detection principle. And lastly, air separation units is another very interesting application area where a reliable sensing technology such as paramagnetic is needed for the production of industrial oxygen. And again, these are just a few examples and well-known application areas among many more that can successfully make use of paramagnetic principle of oxygen detection. Moving towards the features and highlights, paramagnetic principle for oxygen detection is fully linear and thus requires no post-processing or linearization of the sensor output. As mentioned before, Due to the paramagnetic nature of the oxygen molecule, the sensor offers very low cross-sensitivity to other gases, which makes it extremely selective to oxygen. It has a very low maintenance requirement as there are no wearing parts with the sensor module. Again, paramagnetic being an optomechanical principle offers no consumption of gas and simultaneously very long lifetime. And last but not the least, the paramagnetic working principle is ideal for continuous operation, which is not the case for many other different operation principles. This brings us to our last survey for the day, which will be followed by a Q&A session. I thank you all for joining in and participating in this webinar, and I look forward to receive your feedback and more insights about your need for the oxygen sensors. Thank you very much.
So still some people are answering the question during the poll. Let's give them a few seconds more before we enter into the Q&A session. Well, Nauman, thanks for giving us these insights into the different products and technologies and applications.
And also hello from my side, so live hello from my side to all the participants.
So we're now here at the end of the presentation, and we are really happy to receive your questions. Likely we cannot answer them all one by one here. Usually there are many questions, but we will of course follow up with each of you and each question in the following after the webinar. So please feel free to send us. Some first questions are coming in. Okay, so I'll just pick some. So Nauman, why is the portable paramagnetic analyzer that we offer not being operated with battery power?
That is more related to the working principle, the paramagnetic. It's not a very power consuming principle. So it needs a lot of power. And one of the reason is that the sensing principle is influenced by temperature. The heating cell is heated at around 55 degrees centigrade or so. And in order to make it more stable for the detection of oxygen, we can integrate it with a battery, yes, but the battery needs a replacement very often.
Okay.
That's what make this working principle not that suitable for portable application areas where a battery implementation is required.
Okay, thank you. Okay, so here is one other question. Oh, that's interesting. Are any of your sensors approved for use in space applications?
Not at the moment, no. And this is more related to the to the application. So if you have an application of a certain kind, please discuss it with us. We are willing to support it in any way possible. So far, unfortunately, have not been the case, and there has not been any certifications for the use in the space applications.
Okay, and so one more question. Let me try. So what sensor would you recommend for a gas flow application, for example, conveying?
This is something which I would say we can also discuss more in detail. So please come to us, contact us, and we can discuss in more detail. The reason behind is that all the three principles can be used in the gas flow application and also in the, if I understood it correctly, this is more on a conveyor belt application, perhaps. But there are also other questions that needs to be answered. For example, what are the other gases that can have an influence? Then what kind of flows we are talking about, and so on and so on. So please get in touch with us, and we will definitely be able to find a solution with our sensors for you.
Thank Thanks. Tim, this question came from you. I hope this answer was what you expected. If we misinterpreted your question, please just send me another line and I'll try to catch up with it. Okay. Good. So one other question related to the orientation dependence. Yeah, you cannot always install a sensor however you want. So is there anything to be considered when you install the sensor in terms of orientation?
It depends on the technology, yes. So in case of amperometric, I cannot think of any. It's the same situation for, or partly same situation for potentiometric. However, potentiometric is definitely influenced by the orientation. And the reason behind is that there are, again, many other factors. So for example, humidity is one factor. So if you have an orientation where humidity is condensed, that's definitely not suitable for any of the three working principles that we have mentioned. So condensation is absolutely no go. However, the orientation in general can have an influence on potentiometric and paramagnetic working principle, but it also depends how we integrate it. For example, we can have a kind of a bypass solution, where we take the gas sample in, analyze it with the sensing technology, whatever we decide on it, and then exit it back or exhaust it back into the main process line. And with this kind of an approach, it doesn't matter what is the orientation of the sensor. It would, in any case, be working without any issues.
Okay, thank you. So next question, where would a galvanic O2 sensor be preferred over these technologies? I guess galvanic means electrochemical sensor in this case.
These are all dependent on the application requirements. All of these different technologies, they have their own advantages, disadvantages. What we have discussed here is a rather high quality sensors where you need a rather accurate measurement. Electrochemical, on the other hand, it definitely has a price advantage. Yes, I agree. But at the same time, this is, if you really need an accurate measurement, then you need working principles which can offer that in terms of the limitations that the application has. With that said, we also have electrochemical sensors in our portfolio. Again, as I said, this is all dependent on the application. So if it is something which you have in your application as a requirement, please come to us, discuss with us. As I said, it's just not about the sensing technology. It's more about the application. Each of the technology has its advantages, disadvantages. That does not make one better than the other. However, it mainly gives us an indication which technology can suit which application. And that's why also in the webinar, in the presentation, we gave some of the most relevant examples. However, it's also always mentioned that there are many, many other applications. So if you have any requirement, come to us. We want to help you, or we want to support you.
Okay. So next one. There's two questions combined in one. My application is very low ppm reading of oxygen. Which would be the right product for me, and where should I put my pump?
The pump should always be placed after the sensor. That is absolutely is required. Let's put it like this. And the reason behind is the fluctuations that can have an influence on the oxygen reading, and also the pressure and differences that can have an influence on the measurement readings. What was the first question, Volker?
Which of the technologies presented is the best for low ppm reading?
Yes. As it was also mentioned in the webinar, the potentiometric zirconia is one of the very, very well-known technology that has been used since many, many years for the detection of oxygen and ppm level. And the reason behind is that this working principle, or the combination of the working principle, works in such a way that the ppm measurement can be performed very, very accurately. Another thing which I would like to add in our potentiometric zirconia oxygen sensor is the two different measurement ranges. Because our sensor can be utilized with two different measurement ranges, we can calibrate the sensor for your application. Let's take the example of 3D printing or additive manufacturing. When the printing process is being taking place, you really need to get rid of oxygen content, and this goes really in the ppm level. So you need a sensor that can measure very accurately in ppm range. However, as soon as the printing job is completed and the sensor is exposed to normal air or to the airflow, that increases the oxygen content to 21 volume percent. So you need another sensor that can measure, or you need this with the same sensor that can measure also 21 volume percent quite accurately, so that you know that how you can control the printing process.
Mm-hmm. Okay, thanks. I'll stress you a little bit because there are some more questions.
Mm-hmm.
Can you say, or can you mention something on how often do oxygen sensors need calibration, and how about consumable parts to be replaced after a while? Can you give some information on this?
This is more related to the lifetime. Yes, both amperometric and so all three of them, in fact, amperometric, potentiometric, and paramagnetic, they do not have consumable parts. This is not entirely true for the amperometric. Nonetheless, we have tested the sensor with a very, very long lifetime. So in comparison to a typical electrochemical sensor, the sensor can operate under certain conditions easily up to 10 years.
Mm-hmm.
And this is something which gives the sensor a very good highlight or feature that can be used.
Mm. And this, by the way, is of course a benefit. Costs of ownership are lower with these sensors because you don't need to have recalibration spare parts frequently.
Absolutely.
Yeah.
Calibration is a topic. Again, this is something which is very much dependent on the application.
Yeah.
We cannot really fix or say something that the sensor needs to be calibrated once a week or once a month or once a year. We typically recommend it to our customers that please test or check the sensor on a regular basis, at least once a month or once a year. And if the sensor is not behaving as it should, we have developed all three of these sensing technologies in a way that the user can, without disassembling the sensor from the assembly, from the machine, from any application, can recalibrate on site.
Mm-hmm.
And this is exactly what we offer as a support to the customer so that they can calibrate the sensors by themselves. If not, we can also support it. Nonetheless, the sensor, typically what we say is that the sensor should be calibrated once a year.
Mm-hmm. Okay. So we have time for one or two more questions. One interesting question is here. The products that we have presented here in the webinar are likely standard products. How about customizing? Is there anything available when it comes to other detection ranges or interfaces or so?
We are open to it. So this is also mentioned quite a few times during the webinar, during the presentation, that we work in a very, very supportive and flexible way. So if you have a requirement which is not standard or not being mentioned here, just come to us, speak with us, and we would be very, very happy to support.
Okay. I'll give you one last very technical question. The zirconia oxide sensors are heated up to some 100 degrees Celsius. How about the paramagnetic sensors? Is there anything similar?
I mentioned it also. The measurement cell is heated at around 55 degrees centigrade. Yeah. And one of the reasons is to get rid of certain temperature dependencies on this principle. So this is an optomechanical principle, and the force which is being applied, you need to detect it. Temperature, pressure, ambient temperature, ambient pressure will have an influence, and that is why our measurement cell is heated at 55 degrees centigrade in order to protect the sensing element against these deviations.
Okay, thank you. So there are some more questions, but I think we are running out of time. We want to be precise as a Swiss company. We're used to start on time and to finish on time. This does not mean that we do not follow up with all your other questions. We will show you the contact data once more. You find them as well on our website. Please feel free to contact us anytime after the webinar. Send us your questions, comments. If you have any demand for gas sensors, you're very welcome to speak with us. And we would be more than happy to keep in touch with you all. So thanks for joining this webinar. Thank you, Nauman, for giving all these insights. And thanks for you all, for the participants, for the time you spent with us today. Hope to see you next time. Please check out our newsletter and website for the next dates and for the next webinars.
Thank you, everyone. Thank you for your time.
Bye.
Thank you. Bye.